what is a hypothesis? And people say, well, I know what a hypothesis is. And if I don't know, I'll just look it up in the dictionary. And it turns out the dictionary doesn't have a single scientific definition. Okay, so any word you find in the dictionary, for sure, is misdefined for the purposes of science, for the purposes of physics. Okay, so this fellow asks me the following. He says, your ropes are only an assumption, an idea, a hypothesis. And the answer is, yeah, that's what they are. It's called the rope hypothesis. Okay, why? Because it's the object. So, here's my rope hypothesis. Okay, I point to the rope. I say this is called a rope. In any planet in the universe, we call this a rope. Okay, you can buy it at the hardware store, and we're saying that light is mediated, looks like this. If we had the eyes of God and we could see what object essentially mediates light, this is what we would see. We would see something that looks like this, a pair of twined threads. That's our proposal. You can think of it as DNA, helical pair of strands, but they're real physical strands. That's the difference between this side and everybody else in the world. Everybody else uses concepts. They say, like the Electric Universe the other day talked about them and said, they say it's the current, two currents which twine around. Well, current is not a physical object. And then you had Nassim Haramein, I talked about a couple of weeks ago, and again, he says, this energy that twines around. No, energy is a concept. You can't twine around energy because it's not a thing. Okay, and you can't use any of these concepts. You have to use a physical object. We're saying no. Light is made of two physical strands. What is physical? Physical is that which has shape. That's physical. The strands have shape, but you cannot see or touch them. That's the hypothesis. That's the assumption. And that's what this fellow is saying. This is just an assumption. Yeah, that's what it is. It's an assumption. We have to start with an assumption in order to build the theory upon that assumption. So the theory is consistent with the assumptions. Okay? But the problem is people don't really know what an assumption is. That's really where it starts. People think that an assumption is what they learned in high school. They think it's a theory. That they think it's already an explanation, a tentative explanation. Okay, and so we look at some of these definitions that we find out there for the word hypothesis, and these are some I pulled out. Okay, talked about this in the past, so I'll go quickly through them. One says it's a purpose. Another one says it's your question, the question you're going to ask. Another one says it's a tentative guess, okay, a hunch, okay. Some say it's a prediction, okay, that you make a prediction, and that's what a hypothesis is. Others equate it with an assumption, but again, what is an assumption? And people think they know what an assumption is, and they say, yeah, I know what an assumption is. Well, we'll find out whether they know or not, okay. An explanation that requires evidence, with some evidence behind it or without some evidence, they talk about testing it. It says a theory is provisional until, and it's only called, it's until then, when it's provisional, that's a hypothesis, okay? And again, tentative theory, another one says it's data analysis. They have all these notions which are not synonyms, and they call all these hypotheses, okay? This is where the problem is. The word hypothesis is used in so many different contexts. And you wonder finally, what is this person referring to when he says hypothesis? But the main one is that people think it's a temporary or tentative explanation for a phenomenon. Something happened, they say, well, I think, let me guess. And he gives you a theory, he gives you an explanation, he says that's an assumption. I'm assuming that that's what happened. That's more or less the context. But because of that, because they have all these versions, right, of what a hypothesis is, you ended up, or the mathematicians ended up with ridiculous explanations for everything. And here you can see how they ended up with religion, essentially. That's the bottom line. They ended up with all these opinions, beliefs, which they pass through as facts, as truths. And really what they're doing is, giving you their version of religion. That's all they're doing. Okay, here you see one of the consequences of this. It says a hypothesis is a proposition that attempts to what? Explain a set of facts. Okay, is that what it is? Just an explanation? A scientific law, you talk about laws, is a hypothesis that is what? Assumed to be universally true. Well, when you talk about truth, what is true, you're just giving me your opinion because I have a different truth. One person thinks that God is true, the other one thinks that the non-existence of God is true. Okay, so everybody has a different truth, different set of facts. So these people talk about facts and truth as if, they've already proven it and you have to accept it. they shove it down your throat. And I'm saying, well, I don't know. I don't like your truth. Said, well, we've already proven it. So that means I got to memorize it? Is that what I'm supposed to do? I can't challenge it because a group of people decided that what is a fact and that it's true because it's already been proven through experiments and equations and who knows what else, raising their hands, voting for it. No, we have a problem because we shouldn't talk about truth and fact in science. Okay? Evidence, that's an opinion. What is evidence of your wife cheating to you is evidence of the contrary to your neighbor. So, who's right? Well, we have different evidence, we have different facts, different truths. So truth, fact, evidence, knowledge, none of that plays a role in science whatsoever. Science is explanations. We explain objectively so that you understand. You can then believe any facts, any truths you want. Okay? And it says a law has good predictive power. So what? The issue is when they talk about laws, they're talking about equations. And because they have an equation, which they've already determined through measurement, they say now we can predict using this equation. Okay, so you can predict that there's going to be an eclipse tomorrow at 2 o'clock because you measured the eclipses throughout time, and it's going to happen at such and such time, at such and such speed. It all, so you can predict. But that doesn't tell you, for example, why there is an eclipse or why, what causes an eclipse. In other words, that the fact that you know that it's going to happen doesn't tell you what's causing the eclipse. That's a different question altogether. Okay, so if you can answer that, hopefully it means you're going back in time and saying, oh, I know it's going to happen. I can explain what's going to happen because of my experience with this phenomenon. So that's no longer a prediction. Now you're talking about an explanation. Now you're talking about what happened, not what will happen. You know that it will happen. That's a description, a prediction. That so far you haven't explained why. If you can explain why, now you're talking about the past. You're talking about something that already happened. That's why you can explain why. Okay? Anyways, you can see here that it's all belief. They say well-established laws. Well-established by whom? And it says that explains a group of observations or phenomena. Again, one thing is the explanation, and the other one is the belief in that explanation. Maybe someone else has a different explanation for that same phenomenon. Okay, not necessarily an eclipse, but could for whatever. Could be a different explanation. In fact, even for an eclipse, you might find some guy on Earth that says, "Well, I think God comes in front of the sun." And you say, well, no, that's not what happens at all. I know for a fact it's the moon that comes in front of the sun. That's why we have the eclipse. And the other guy will insist that it's God. That's God that stands in front. And what are you going to do? You're going to say he's an ignorant. Yeah, he's an ignoramus, but I mean, that's what he believes in. That's his set of facts, that God stands in front of the sun. That's why there's an eclipse. What are you going to do? Kill him? Because that's what he believes in? So again, belief, opinion, we don't care about. Not in science. In science, we don't care. What we care about is the explanation. What is your explanation? This guy says it's the moon. The other guy says it's God. Great. They have two different explanations. You now can believe in whichever one you want. Okay, that's not science. That's religion. The scientific part is how do you explain this phenomenon? That's science. Okay. Anyways, broad acceptance. Broad means that you have to swallow it because a group of monks have already determined something for you. Now you have to believe it because it's got broad acceptance among the ruling classes within the scientific community. Okay, and again, they talk about prediction, they talk about authority. Okay, so this is what the word hypothesis has taken us to because they think that hypothesis is some kind of explanation, then tentative explanation. From there, it proceeds to an explanation that has more evidence, proof, knowledge, whatever you want to call it, behind it. Okay, so now it becomes a theory, and if more people vote for it, if the whole congregation votes for it, now it becomes a fact. Now you have to accept it because a group of monks have decided that space-time is warped, and you just have to accept it that that's the explanation for gravity. And if you don't accept it, well, then in the old days they would have crucified you, killed you, somehow tortured you, Inquisition. Today they just ban you. They just say, well, you're a crank. So. And you're outlawed from, any so-called scientific forum. That's how it's done today. Okay, and again, is accepted, completely accepted. And again, all this has to do with belief and not with science. Science is just the explanation part. Tell me the mechanism, and I'll figure it out on my own if I'm going to consider it a fact for myself, a truth. If your theory morphs into a fact for me, that's the way it works. Okay, so here. Let me show you that assumption is not a theory, and a theory is not an assumption. In other words, the assumption is not an explanation. And people say, yeah, because I'm making an assumption that this is how it happened. And that notion is what they've introduced into science. And they say, a hypothesis is an assumption. Yeah, correct, but because it's an explanation. No, not at all. Hypothesis, assumption has nothing at all to do with explanation. So let's show a couple examples so that you see why assumption is not an explanation. Assumption is not, let me assume that this is what happened. No, that's not an assumption. So here, let's look at some cases so that you can see the difference between a hypothesis and a theory, between an assumption and an explanation. Okay, so here it is. Okay, in science, right? Assumption is not an explanation. And here we have a couple of examples. Okay, assumption, a hypothesis, right? That's the word, that's a synonym of hypothesis, assumption. Let us assume that planet Vulcan, right, for example, exists between Mercury and the sun. That's just an assumption. So far, I haven't explained anything. I'm just making an assumption. What if there's a planet there between the Mercury and the sun? What am I trying to explain with this assumption? I'm saying, well, the mass of Vulcan might be able to explain, why Mercury has this perihelion shift. Okay, why it has this Rosetta-like orbit. It shifts every now and then. Okay, so the explanation is that I'm trying to get to, right, is why Mercury behaves as it does. That's the explanation. I'm giving you an explanation for that. What assumption am I making? I'm making the assumption that there is a planet somewhere between Mercury and the sun, a tiny planet, some mass out there, and that's causing the Mercury to go in weird orbits. Okay, so the explanation here is obviously nothing to do with the assumption. Let's look at another example, which is more typical of what people have in the back of their minds, and that is, let us assume that the window broke when a hard object struck the glass. Now that sounds already like an explanation. People say, oh, you already gave me an explanation. You're saying a hard object was what caused the window to break. But see, that's not the explanation I'm getting to. That's not the one that I'm trying to explain to you. It was an explanation which I've now converted into simply an assumption. Okay, I'm saying let us assume that a hard object is what broke the glass. I'm not giving you a theory of the hard object breaking the glass. I'm making that as an assumption. Okay, and what am I really trying to explain? I'm trying to explain that it wasn't Johnny who hit the glass with his baseball bat. It was the dog who jumped through the window, another hard object. Okay, so the theory is not the explanation I gave you as an assumption, because that is not the target explanation. That's used as an assumption. I'm just making that assumption. I'm making believe. I'm asking you to make believe, to make that assumption that a hard object is what broke the window. That's not the explanation I'm targeting. The explanation is, what caused it. And it wasn't Johnny with his baseball bat. It was a dog who jumped through the window. Okay, so hopefully you can distinguish that an explanation is not an assumption, at least in science. In ordinary speech, people say, well, you made an assumption, and that's your theory. No, that's not my theory, that a hard object broke the window. My theory is that the dog jumped through the window. That's how it broke. That's my theory. Okay, and I use the other one as an assumption. Okay, so here we have my definition. Okay, this is the one for hypothesis. What is a hypothesis for the purposes of science, specifically for the purposes of physics? Okay, science, rational explanations. What am I going to do? I'm going to explain in a rational manner. Okay, I'm going to try to explain what a mechanism in the case of physics, right? I want to explain a process, what a phenomenon. Okay, I want to know the causes of that phenomenon. For this, I have to start with a hypothesis. What did this fellow say? He says, oh, it's just a hypothesis you wrote. Yeah, that's all it is. This is a hypothesis. Okay, this is just an assumption. I'm saying, let us assume. Please make believe, right? That's what we're saying, that light is mediated by a rope-like architecture. Okay, and so that's how Mother Nature is going to do all this stuff according to us, according to me here. Okay, so we're saying that's the object I'm presenting. I'm saying, what's the object? I'm saying it's a rope. Okay, a rope-like entity. It looks like this if we had the eyes of God. It's not this one. That's not the one you buy in the hardware store. It just has that configuration. That's what we're saying. Okay. Then we have to have the definitions. We better have good definitions, especially for the word object. Okay. If you're going to use an irrational definition such as see and touch for the word object, well, you're going to have trouble because not all objects can be seen or touched. And then if you say, well, let's go to the lab to prove my theory, well, there's nothing we can prove because we can't see or touch the mediators of light and gravity. So, you started out with a wrong definition, an irrational definition of the word object, and that's why definitions are very important, and they are presented at the beginning of your presentation. That's part of the hypothesis. Hypothesis includes the objects, the definitions, and also the statement of the facts. Does it include the facts? No, absolutely not. Facts are what Mother Nature knows for a fact happened. She knows exactly. She's got that piece of video, all the frames that happen exactly, and she's got it filed in her cabinet. The problem is we have no access to that cabinet. It's already in the past. She has this past cabinet, and everything that happens falls into that cabinet. So she knows exactly what happened, but we don't. We can only make an assumption, and so we call that a statement of the facts. It's your version of what you think happened. Okay, first frames, you present the initial scene, so to speak, right? And on that, you're going to build your theory. Okay, and the theory is going to be, the explanation of some kind of cause, mechanism, whatever, okay, phenomenon. So this is our version of what a hypothesis is. Hypothesis is not a theory as it is in mathematical physics and in so-called science today, where they say, look, hypothesis is just an untested theory, a tentative theory. It's a theory that has no significant or any evidence whatsoever behind it. It's just like a temporary guess, a starting point. That's not what what a hypothesis is. It's an assumption. An assumption is not an explanation. Explanation is what a theory is. So please do not confuse hypothesis with theory or with explanation. Hypothesis and assumption, okay? It's necessary in the scientific method. That's how we use it in this site. So when you come with your little birdies from mathematical physics, or you come with your ideas from high school and say, well, this is what it used to be over there, it was a tentative theory, you came to the wrong site, okay? And we urge you to go to another site, please. Okay?